Hi everybody, it's time for lesson number 14, which is called Single Replacement Reactions. In this lesson, you're going to identify what single replacement reactions actually are and predict the products, what's going to be produced. And we're going to talk about something called the solubility table. I think now what's going to happen is everything's going to be in place. Very much on purpose, I've been leaving certain aspects out of this course so far, but I think now everything will be in place for writing a correct chemical formula. I've often liked this picture down here below. It helps me remember single replacement. So basically, you have guy A, guy B, and girl C are dancing. Guy A is going to replace B. Now A and C are dancing, and B is by himself. He doesn't look too happy anymore. Anyway, that's kind of the general overview of what a single replacement reaction is. I would like you to take a moment and grab your periodic table or your data booklet. And if you could go to, in your data booklet, it's page number 6. In your textbook, it's page 57, I believe. Yes, page 57. One thing we have to do here, everybody, is when we have a product made, we have to state if it is solid or aqueous. Now, before I get into how to do this, let's talk about what's going on here. Let's say we have a reaction. So we have A plus BC, and just like that dancing example, A comes in and kicks B out. So now B is by himself, A and C are together. When we have a compound, an ionic compound, why do I put O there? Ionic compound. We must state whether this compound will remain a solid in water or if it will break apart into its ions. Now, what I mean by that is this. Let's say you have a solid. So there's that AC again, okay? So our product, remember, our product was AC. Now, let's say we take a little container of water, and we take AC and we dump it in. Now, in some cases, AC is just going to fall to the bottom in a clump, and it's still AC. Well, guess what? That's a solid, and we give it a subscript S. The alternative is sometimes what's going to happen is we're going to take AC, we're going to dump it into the water, and it's actually going to dissociate or break up into its ions. So it would be a positive A plus and a negative C minus. This is called AQ for means, and that's going to be basically when you put it into water, it breaks apart and dissociates. Now, on the table, you feel free to put this in here. See where it says right here, solubility greater than or equal to? It means very soluble. You can put an AQ symbol right here. You also can put down here solubility less. That's going to be your solid. So what you have to do now whenever you write a chemical equation is you have to figure out, is your ionic compound going to be aqueous or soluble? So what I mean by that, again, one more time. I have to put this back. You have A plus BC. This side is called your reactants because they are reacting. Now we're going to have our products. B is by itself. A, C have come together. This side is called your products. And whenever you have an ionic compound on your product side, you must determine its state of matter. It could be AQ, it could be solid. And that's what you must use this table for. As we move forward here, everybody, I'd like you to ensure that you have this table in front of you. and we're going to kind of go from there. One other rule of thumb I think we can kind of stick with right now is some other little pieces of information. I'm just going to give you kind of a basic example. Let's say you have, we'll do sodium plus chlorine like we've done 10 million times. Remember, chlorine has to have a 2. Sodium is a metal. So until you're told otherwise, we're going to give metals are going to be a solid. They come in as a solid. If you look at the periodic table, chlorine has that kind of the bluish color to it, and that's a gas. So basically, when you do this, you have to kind of look at your individual elements, and we'll do that as we go along. It'll be pretty self-explanatory. And then you use the table to figure out if this is solid or AQ. And we're going to do that right now. Okay, let's move on. So what we're going to do, I'm going to give you some basic examples here. And I'm going to ask that you have your table in front of you and help me along with this. So what you have, let's try AgCl. Now, you're like, well, how the heck do I use this table? It actually isn't too hard once you get the hang of it. What you do is you always look for the negative ion. So step 1, look for negative ion. In this case, you can tell, remember, Ag is a metal, so it's a positive. Cl, remember if we did this properly, Ag is +1, Cl is 1 minus. So it's always the back one here, guys. The back one is your negative. So what you're going to do is you're going to now go onto your table and you're going to find Cl. I'm going to go back a page. Okay, where is Cl? So you're looking up here. You're looking up here right now. Do you see Cl? Cl is right here. Okay. Now let's go back to the other page for a second. Find the negative, or pardon me, the positive ion by going down the column. I will go back now. So we have our Cl minus. Let's find Ag. So here's Cl. Let's go down. I don't see Ag here. Oh, Ag is right there. And if you remember, we put this was our AQ category. This is our solid category. So we found our negative. We found our positive. That means that this compound would be solid. Let's try another one, just for the heck of it while we're here. Let's try AuNO3. Okay. Number 1, look for negative ion. In that case, it's always, remember, it's always the rear one. That's the NO3 minus. So let's go back. Now, we need to find our NO3 minus ion. Okay, so let's put that together now. Well, pretty clearly you can find that. NO3 is right there. Number 2, look for positive Au ion. Okay, let's go back. All right. Oh, this one says most. Let's go down and find Au. Nope. Au is not one of these. So if it's not one of those, it must be one of these. Remember, this was AQ. This was solid. So this would get an AQ. If you put this into water, it would separate into its charged ions. I believe Au is 3+, and NO3 minus is 1 minus. I will give you practice with this, but it's a pretty straightforward process. It's just you have to find, you always look for the negative ion first and then use a table from there. If you want, I can certainly show you one more here. It's not a big deal at all. Let's maybe do a little bit quicker. I'm just going to erase all this. Of course, you guys can rewind everything. So let's just try, I don't know, let's go, NH4OH. Okay, so where does that go? Well, OH is your negative ion. Go back to the table. Whoa, here's OH right there. Go down. Oh, there's NH4. That's in that line. Okay, must be AQ. We could try another one. We could do, really the options are endless. Copper sulfate. Well, by now you should know this is your negative, that's sulfate. Let's find sulfate in that table. There's sulfate right there. Let's go down and find copper. Oh, I don't see copper in there, so it must be Cu. Sorry, it must be AQ. Anyway, everybody, I hope you're getting the hang of this now. That is important to know how to do the solubility table. All right, so now we're going to start putting all this information together to help us with single replacement reactions. Remember the simple overview is A plus BC. This is an element. This is a compound. There is going to be a switch here per se. As an example, B might be kicked out because A comes in and takes over. So that's going to be plus AC. This is your new element. This is your new compound. Remember, this is your what side? This is your reactants. And these are your products. Please keep in mind, we need to balance everything. Balance charges. Remember your diatomics. And remember states of matter. All right, here we go. Let's try some out. I hope that you find this fairly easy because we have spent a lot of time on ionic reactions and so on and so forth. So I like to think that you will be able to do this fairly straightforward. If you want to follow along in the textbook, I'm just going to try to find you here, find the right page number, because I do think a lot of you probably do enjoy following along in the textbook. At least I know I do. In the textbook, this is on page 96. Okay, let's try to do some examples here then. Here we go. Okay, so, it doesn't really matter what we take. Let's take, let's go with magnesium plus NaCl. Okay. Now, magnesium, that's going to be our A. This is our BC. Now, magnesium is a standalone metal, so that's going to be solid. Now, NaCl, if you look at your data table, and what I mean is page 6, I'm hoping that you will be able to determine whether NaCl is solid or aqueous. What you do remember is you have to go and look for your Cl, go down, you will find that this is aqueous. Okay. Now, there is a bit of a strategy here, but it's not just a random guess. I'd like to just kind of make this a little bit neater here, sorry. So you have Mg solid plus NaCl. Here is what you must consider. You see A Is magnesium a metal or a non-metal? Well, it's a metal. If you look at NaCl, this is a metal and non-metal. It's ionic. What this means then is that this metal, it only replaces another metal. You never would have a metal replacing a non-metal. It is the metal replaces the metal. Same replaces same. So if you go over here, what's by itself now? This magnesium came and replaced sodium. So sodium should be by itself. And what's come together now? The magnesium and the chlorine. And you always write the metal first. So it should be MgCl. Couple of things here, everybody. Please remember, sodium is a metal. It gets a state of solid. Now let's focus our attention right here. Very important. There are two things that we have to do right now. Look at the charges. Mg is 2 plus. Cl is 1 minus. What's our charge of Cl? Well, it better be a 2. I'll put it right there. That's magnesium chloride. One last thing that we need to do. What is the state of matter of MgCl2? If you look at your table there on page 6, you will be able to follow that and determine that this is an AQ. So there is a lot to do here. There is a lot. But it is a flow and a pattern that repeats itself over and over and over. We will try another one and see how this goes. All right, this time let's go with, let's try doing it with words. Copper 2 chloride. Oh, I'm sorry. Let me just back up for 1 second. Sorry. We're going to go with aluminum. Reacts with copper 2 chloride. Okay, so in this one's a little bit harder because we actually have to write everything. They don't give us the starting formulas, so we have to write that ourselves. So aluminum is Al. Now aluminum should be a solid because it is a typical metal, and that does seem to work out. Copper 2 chloride. You can't just write that down, everybody. You have to look at it. So copper is 2 plus, that's from the 2, and chloride is 1 minus. When they come together, that'll be CuCl2. Now we can put that up there. Now, what are we missing? We are missing our solubility table there. In this case, if you do it properly, I believe this is going to be a solid. Okay. Sorry. There also are times they might tell you otherwise, but I'm just trying to help you guys out here with the naming of the states. Okay, so then this is our A, this is our BC, this is a metal, this is going to be a metal plus a non-metal. This metal is going to kick this one out. So then over here the flow is B plus AC. Copper should be by itself, that's going to be a solid, plus we should have Al and Cl put together. We have two things to do here, everybody. Number one, the charges. Al is 3 plus, Cl is 1 minus. To me, that means we need 3 here. We're almost done. Then we need the state of matter. If you use your table, that should give you AQ. There is a lot of work there, and I do agree with that. But essentially, and believe me, as you move on, this actually will become a fairly quick process, because you see, once you truly understand everything, you can simply take this and go for it. When you get to that point, of course, this will not be as difficult of a process, and life will be a lot easier then. So, should we try one more? I'll do one more with you. Maybe I'll even do it. I'll do it perhaps more quickly with a little bit less assistance. Okay. This one's going to change things up just a little bit. Let's do chlorine gas plus AgBr. Okay. And I'm just going to say solid in this one. Let's be easy with this. Now something's changed. This is your A, this is your your B, your C. But this is weird. Look at this. Chlorine's a non-metal. So what is it going to replace? Because silver is a metal, bromine is a non-metal. That means this chlorine is going to replace the non-metal. Non-metals replace non-metals. So by itself should be bromine. What are we forgetting here, everybody? Bromine is one of the diatomics, so you must put a 2. I'll even give you the state of matter. It's liquid. Plus, what's the new compound? Well, chlorine and silver are coming together. How do you write that? Well, I know the pattern, but the point is, everybody, you always write the metal first. So it should be AgCl. Okay, AgCl. I'll even give you the state of matter. It's solid. Let's double check that charge. Ag is 1 plus, Cl is 1 minus. Yep, AgCl. Perfect. That is a complete simple replacement reaction. We will need practice with this, and we'll go from there. Thanks.